So hi everyone. So as you have heard, my name is Fridah, and a little bit about myself. So I'm working at MCOP at the moment. I just joined like 2 weeks ago, so 2 weeks old. And beforehand, I was working at Busara Center for Behavioral Economics for like around 3 years, where I was a lead data analyst. So like every time I'm always using R. Like R is my go-to tool all the time in my work. About my background, statistics background, and then so kind of right now at MCOPA, like my typical day is a lot of SQL, because most of our data is in databases. For people who don't know SQL is a structured query language that is used to query data from databases. If you want to get data for analysis, you have to get it from the database using SQL. And some other times, maybe in meeting the stakeholders, kind of understanding their problems and kind of thinking of how to solve their problems. And then a lot of R, and also meeting them maybe to present the results, something like that. So objective of the workshop today. So today we'll be doing data wrangling. That's a very fancy term. That means basically transforming your data into a format for analysis. So it involves so many activities, and I'll just talk about a few today. So I'm hoping by the end of the session, you will be able to learn how to subset data from different R objects, and also learn how to, use if statements in your analysis. Another objective is like how do you handle repetitive tasks using for loops and the apply family of functions. So the workshop assumes that you have basic knowledge of R, I'm hoping, and that you have R and R Studio installed on your computers, because we'll have some session of exercises to work on. And then like you understand the different data structures, like do you know what a vector is, a list, a data frame, a matrix or an array in R? And I think that was covered during the last Maktaba session. You also understand like different data types in R, like what is a string variable, what is a character variable, what is a numeric variable, a date variable, because that is really helpful when you're working with data, like knowing which structure am I working with and which data type am I working with. So some of the important things to note for our session is, I hope all of you already have the data on your machines, hopefully from the link that Alfred has shared in his presentation. So for each session, we have 3 sessions. The first session is on the subsetting. Second is on the if statements. The third is on the apply family of functions and loops. So after each session, we'll have an exercise for you to try out to implement whatever you have learned during the session. So as an introduction, so like if someone asks you like who is a data scientist, I know there are so many, definitions out there, but my understanding is anyone who can use data to solve a problem, come up with insights and knowledge to help advise probably a business to make decisions, maybe to improve their sales or reduce risk in their businesses. So data science project is a project where you use data to solve a problem, and it normally has a workflow. There's a very extensive workflow called CRISP-DM, so I won't talk about that today, but I just have kind of a shortened one. Because like before you begin a data science project, you need to have a goal in mind, like what am I trying to achieve? And then once you define the goal, you need to come up with like, where do I get the data to help me solve this problem? So you get the relevant data. Then the next step is, you need to take this data and transform it into a format that can be analyzed, which might involve a lot of cleaning, or maybe removing anomalies, or even filtering, for instance. And then the next step, once you have clean data for analysis, you need to be able to analyze the clean data, of course, and then communicate the findings. So today we'll be focusing on the third step, like how do we prepare data for analysis. So I hope you all have the data. So I'll request you to create a folder, like give it any name. I think for me, I have a folder here called Code Maktaba Data Wrangling R. So create a folder. And then within the folder, create another folder called data, where you're going to store the data that you have that you have downloaded. And then you can have another folder for storing your scripts, like the code. For instance, other people, if maybe you're going to have any outputs, you can also have an output folder. So basically, before you begin any R project, like make sure you have a folder somewhere with all these subdirectories so that you can be saving the different outputs or data in the different folders. And then, so once you have your folder in place, so the next step is, of course, open your RStudio, and then create a project. So like most people don't really create projects, but creating a project is a nicer way of organizing your work. And it makes it easier for you to be able to access the different subfolders within the project folder. Because sometimes people are like, oh, okay, I have my R script, maybe let's test the working directory first. Oh, sorry. Okay, fine. So maybe let me a little bit slower because I talk fast, sorry. So do you already have a folder? Maybe let's start from there. Let's create a folder first. And then create the different subdirectories that I've mentioned, like create a data folder. And then put there all your data that you have gotten from the Google Drive. And then have another folder for code. You don't need to have the output one because we won't be having any outputs today. So maybe let me give you around a minute or so to do that, and then we can continue. Okay, fine. So once you're done with the folders, let's open our RStudio. And then, so under File, you can either create like a new file, which could be an R script on an R Markdown or a notebook, depending on what you want to do. But today, we're using an R script. But go to File, and then go to New Project. So go to New Project, and then you will have a dialog that comes up asking you, like, how should we create the project? So select the second option, which is existing directory. I think since I already have mine open, let me just open a new one. Okay, so I have my RStudio open. So go to File, New Project, and then Existing Directory. And then you're going to be asked like to browse to where your directory is. So let me assume my directory is called, I don't know, maybe work, for instance. So I'll just open work, open, and then now create project. I hope everyone is at this point. So if you look at the topmost corner, you can see the name of your project here. And then from here, you can start any R script that you want to start working on. So hopefully everyone has a project in place. So let me just go back and open my project that I had. So once you get a project, R is going to create a file with the name of of the folder that you're working in. So for instance, my folder is called Code Maktaba Data Wrangling R. So my project is going to be called the same name. So if once I work on my project, I close it down, then the next time I want to open it again, I don't have to come and open the script directly. I have to open the project with it has an R project type. So I have to open this. Then now I can open any script that I have from my computer. But since I already had mine open, that's why it's open at the moment. So once you have your R open, okay, sorry, let me just go back to this one. Where was I? Okay, so for me, I'm using an R Markdown. So R gives you a different files that you can work with. So an R script is like this one. It's just a blank editor for you to, you can put comments, you can put your code. Okay, you can put your code and everything, but then an R Markdown It allows you to document the whole process, allows you to write a report, which you can save as a HTML file or a PDF file or a Word document. So today, so for me, I'm using the R Markdown, but when you're doing the exercise, you'll be using the R script. So the first step is, of course, I have my script open. Now, what do I need to do next? You need to, first you need to put some comments, like you need to put sections in your code. So like for instance, my first section is, I want to start importing libraries. I'm going to use packages. So a package in R is just a collection of data, functions, and compiled code that is formatted in some format for you to be able to load into R for analysis of data. So normally when you install R, we call it the base R. It comes with a few functions that you can use for analysis. But R allows you to extend its functionality by either creating your own functions or installing packages that have already been installed by people. So most of the R packages are stored in a repository called CRAN. So you don't really have to go to CRAN to get the package. You just need to know the package you need to use, and then now you need to use the function install packages, and then the package name to install a package. Sometimes you might be required to specify the repository, but that's not, most of the time, not normally asked. And then once you have your package installed, then you need to load the packages into your environment using the function either library. Some people like using the function require. So I'm hoping you already have installed dplyr. This is for data management. Par is mostly contains the map functions for helping the looping process. And then the function readExcel, the package readExcel, it provides functions for importing data into R. So once you have all this installed, then you can load them. So another easier way of installing packages is you just go to, there's a tab, packages, in your studio interface with a button called install. So you just go and click on the install, then type in the name of the package, and then you also check these install dependencies, because most of the packages, they depend on other packages to be able to run effectively. So if you don't install the dependencies, you're going to have issues with running your functions. And then, so the repository is always CRAN all the time. But then if maybe you have a package on your computer, then you can select this option and then browse to where the package is to install it. Okay, so once you have your packages in place, I think you're good. So I think let's dive directly into the first session, the subsetting. Okay, so what is subsetting in R? Subsetting, the goal is basically to extract the relevant information that you want to use for analysis. And there are different ways of subsetting. You can either use indices, which are the column, the positions of the items you want to subset, or you can use logical expressions, which are kind of true and false statements, or you can use the names of the objects. So during the session, we're going to demonstrate all these different ways of subsetting. So let's do a recap of the data structures. So I had mentioned we have vectors. So a vector is a one-dimensional object, and it can only be of the same type. You cannot have a vector where we have numeric data and data that is of string type in the same vector. So it is only of one type. And so I have an example here. I want to create a vector called age, and it contains the age of 5 people. And I want to give names to my vector. So what I need to do is I have to give my vector a name. I'm calling it age. And then this guy here is called an assignment operator. Some people use equal sign, but then I love using this one. It looks more fancier. And then you have to combine all the elements in the vector using this function called C. So you have to get C brackets, and then the names, the ages that you want to put in your vector. And then, so the names, they have to be of the same length as the vector. So like the first age is for Jane, for instance. And so to assign names to my vector, I have to use this function, names age is equals to these names. So what if I want to extract like the first element from my vector using indices? You just use say age and then block brackets 1. It will just going to give me the first element. If I want to extract the first 3 elements, I don't have to say maybe 1, 2, 3. I guess say 1, 2, 3. And if I want to extract elements such that I want to skip 2 and 3, I have to put the indices in the C function. So if I run this, I should be able to get, like this one, I should be able to get 22 because that's the first element in my vector. So to run this, I need to use control and enter. Then, I need to run this first. Control. I can just highlight and then use the run button up here. So age is control enter. And then I can see the first element is Jen and is of age 22. So if I want to run the other ones, I can just still do the same. I have to make sure that the cursor is at the same line as the code. So control, then I'm going to have the first 3 ages, which are 22, 56, and 23, as my output. The same for this one. So if I want to use names to subset my vector, I just need to know the name that I want. So maybe I want the age for John. So I just say age. Then I use the braces. Then I have to specify the name in quotes because it's a string. So if I have this, I need to be able to get, something's wrong. So control, enter. So I'm going to have John is of age 12. Sometimes you might want to use, like I want all the ages that are above 30. So here you're going to use logical operators. So the outcome of this run is a true-false. It's a true-false vector. So let me just run it, show you how it looks like. So you can see, if you look at Jen, her age is less than 30. That's why it's a false. So R is going to only subset where it is true. So then if I run this, I should be able to get people who have ages more than 30. You can also use negative indices, for instance, to drop out some of the data that I don't even need to use. So I need to attach a negative before the index. So if I run this one, it should drop the first and the second elements from my vector. So, and only give me the values for 23, 45, and 12, and drop the first 2. So that's basically how you subset vectors. I don't know if someone has any questions on the subsetting of the vectors. Huh? Yeah. Oh, yes. So the negative sign, if I want to drop some elements in a specific position. So if I want to drop the first one, for instance, okay, let me remove this one. If I want to drop the first one, I put -1. So if I run this, if I run control enter, I'm going to get the last 4 minus the first one. So if I need to drop more, I can still add more to the index. So any questions on the vectors? Okay. So I think we can go to the lists. So a list is, I call it a generic vector that can hold any object. It can hold a vector, a data set, another list, anything. Any object in R can be held in a list. So we are going to demonstrate how to create a list that has no names and one that has names, and then how to subset them when I want to extract different objects in R. So an example is, I want to define a list. To define a list, I need to use a function called list. And then in brackets, then I have to specify what are the elements of my list. So if I look at my list is called list 0. That's the name of the list. Then I assign it to this. So my first element of the list is just a set of numbers. Okay, the second element of my list is a set of is a list of objects, a list of fruits, for instance. And then the last element of my list, you have to separate them with commas, is called iris. So if I run this, Then R is going to display it here under the environment tab. So you can open it to see what are the contents of my list. So my list, as you can see, it has 3 elements. So the first one is a vector of numbers. Second is a vector of fruits. Last one is a data set. And if I click here, I can be able to see my data set in full. So the data set is called Iris, and it has all these columns. So now I have my list, but then I want to extract the first element in my list. Now in this case, for the vector, we were using single braces, but for lists, you have to use double braces. So if I run this, I need to be able to get the first element, which is contains 23, 45, 67 to 89. So in this case, my list has no names. So the next point is, what if now you have a named list? So for a named list, you need to assign names to each of the objects within your list. So in this case, now I'm assigning age is going to be like this list of ages. Then the next one, the next element of my list is called fruits. Then it's going to contain a vector of fruits. Then the last one is data. So if I run this and then I open it from the viewer, I need to be able to see like the names of the list. So age is a vector, fruits, then data. So if I want to extract, for instance, age of fruits, I'll just basically use the name of that vector. So there are 2 ways. So if I use a single brace, the output is going to be a list. But then if I use a double brace, it's going to give me the vector in its raw form. So let's just demonstrate how it looks like. So in this case, I'm going to have a list of fruits. But then if I run the second one, I'm going to have a vector of fruits. So there are different ways in which you can subset data. So just like choose like what is more comfortable, convenient for you, then you use it, depending. But then of course, good practices, always name your lists. It's easy at least to be able to know what each of the elements in a list mean. And then you can subset them using the names. Okay, that is all about lists. So make sure you have put your script in your working directory, the one that you set before. So let's just go to the section of vectors. As I had explained, a vector is a one-dimensional object. It can either contain just numeric data or character data. Oh yeah, let's go to line 92 of the R Markdown file. That's why we are defining a vector with the age of 5 people. So to be able to run like line 92, 93, and 94, you have to select all of it. And then click on the run, and then run selected lines. Or if you're a fan of the keyboard, you can just put the cursor close to the line you want to run, and then click on Control Enter. Then it's going to run. So when you run you create the age vector, you have to go to this environment tab. Then you can see under the values tab there is age. Like you have to be able to see it there to know that it has actually run in the first place. So you can try running this, and then if you, by any reason, you don't see the output here, you can always ask the other team members to show you around. Okay. So we have our vector age. We have given it a names. These are the names of the people whose ages we have here. So we want to subset using indices. So I want to be able to get the first element of my list, which is the age of Jen, which is 22. So what I need to do is I need to type the name of the vector and then put braces. Then within it put the index, that is the position of the age I want to extract. So once I have this, I have to put the cursor close to the line I want to run, and then click on Control Enter. Then if I scroll down, I can see the age. The output is normally shown immediately after this chunk of code. So I can see Jane, the age is 22. So if I need the first 3 ages of the people that I want to see, Still the same. I need to specify the name of the vector, then in braces, specify the positions of the edge that I want to see, then just run. Then if I run this, I should be able to see the edge of 3 people. That is the first 3. So the same case for line 99, where I want to see the edge in position 1 and position 4 of my vector. It should give me like 2, because I only have 2 positions I'm looking at. So you can even try out with, you can change this 1 and put 2 to see what, I don't know, the output. So if I change to true, I can see 56, which is Joyce. So if I go back to my vector, I can see like 56. So anyone who's maybe stuck with the indices, using indices to extract elements from a vector, you can always have the team help you out. Okay, so is everyone okay? We can move ahead to see how you can extract elements from a vector using the names of the vector. Okay, seems everyone is okay. So if you go to line 102 of the file, you can see you're trying to extract the age of John. John from the vector called age. It's just the same case. So instead of putting a position, now you put the name that you want to extract. So the name has to be in quotes because it's a character. But then for numbers, you don't have to put quotes. So if you run this, you should be able to see the age of John. So in this case, I want to only filter out the age that are ages that are more than 30. So in this case, I use an operator. This one is called greater than operator. It's an I don't know what they call. We have relational arithmetic. Yeah, I think that is relational operator. So I have to specify if I need it to be Control Z, like less than 30, just change it, or less or equal to, I have to use that one. And then if I run this, it should give me the edges that are less or equal to 30, which is now Control Enter. So it's going to give me 22, 23, and 2012. So anyone with a question on how to use logical operators in filtering out? Okay. So you can try running it on your own and change the numbers. You can even say, let me try with 50. See what output I can get. At least to be up to speed on how it works. 50. And then now the last section was, what if I need to drop some element from my vector? So in this case, I want to drop the first one. So to drop the first one, I have to give the position of the whatever I want to drop, and then I'll put a negative before. So if I run this, it should give me the second up to the 5th elements of my vector, which is 56, 23, 45, and 12. So I hope everyone is clear on how to subset vectors. Unless someone is stuck or has a question, you can always raise it. Let's then move on to lists. So I had mentioned a list is like a vector that can hold any object, any. You can put a vector inside it, another list, a data frame, or any object that you have in R, you can put in a list. But then the good practice is, like, always name your lists. But if you don't have names for them, you need to know the positions of the elements you want to extract from the list. So to create a list, use the function list. Put brackets, and then I'll start specifying the different objects in a list. I can even add another object that is just a number here, like 9, for instance. But then, so in this case, my list has how many elements? It has the first element is a vector. The second element is a character vector with the names of fruits. And then my third element is a data set called iris. So R, when you install R, it normally comes with some inbuilt data sets that you can play around with. So to be able to see these data sets, I can run the function data. Then I put brackets. So highlight this and then run. then it's going to open a list of data sets that you can be able to try out. If you want maybe to learn something in R, for instance, I can come here and check, okay, maybe let me load a data set called air quality. It contains air quality measurements. So to be able to load it, you can just either call it directly. Like for instance, in this case, I want to call, let me have an object called df, assign it air quality. And so when you start typing, R will suggest for you names of objects within it. So in this case, I want to load this data called air quality. So if I run this one, it should save, assign air quality data to the df object. So if I come here, I can see my data set. So that's why I'm directly calling iris, because it's already within R, so I don't have to worry about like where to get it. So once I have my list is created, so highlight this section of code and then run. Then if it runs successfully, you should be able to see the list under the data section. So you have the data section and then the value section. This one normally stores functions and vectors and shows lists and data sets. So if I open the list by just clicking on it, I can be able to see the elements of my list. And if I want maybe to extract the second element, I need to use block. You can even see R is suggesting to you how to extract the different items from your list. So in this case, the example that I have here, I wanted only to extract the first element, which is a vector of numbers. So this is how you do it. Specify the name of the list, then double braces, then the position of the element you want to extract. So in this case, if I run this one, I need to highlight it first if I'm going to use this one. Then I can see the elements that are in the first element of my list contains those numbers. So any questions on the lists? Okay, on the list, okay, I think we are fine. So now I want to talk about a named list. So this is a list in which all the elements have been assigned a name. And to create such a list, it's just the same procedure, but then the difference thing is you're adding a name and equating it to each element of the list. So as you can see you have the list function, and then within it, my first element is a vector of ages. So I put age is equals to this. And then the second element of my list is called fruits. So I have to put it like fruits is equals to, and then I put a vector of fruits. Then the last one is called data. So if you highlight this one and run it, make sure it's appearing under the data section. Then you can open to just see how it looks like. So you can see, like my first element is called age, and there's a list, like the values are displayed here. Second one is a vector of fruits. As you can see them, they are here. And then the last one is a data set. So to extract the elements from the list, it makes sense to be able to use the names of the elements themselves. So in this case, just specify the name of the list. It's called named list. The double braces, and then the name of the object, which is called fruits, in quotes, because it's a string. So if you run this, I should be able to see oranges, apples, and all kind of stuff. So I can see I have orange, apples, mangoes, bananas, all that. So I want us to talk about another object in R. Apart from having lists, having vectors, we have data frames. And I think most of the time, we're always using data frames. So a data frame is a two-dimensional object with columns and rows. So the columns are the variable names, and the rows are the different observations or the different cases in a data set. So there are different ways of importing data into R. I don't know whether people have tried doing it before. You can do it manually from here. Under the environment tab, you can just come say import data set, then specify the format of the data set. Like the one I've shared with you is a CSV format. So in that case, I need to use from text. If it's an Excel file, I need to select Excel. So if I click on this one, it should give me a dialog box asking me where's the location of the data set. I have to browse to where it is. And then, like R is very good. It even gives you loads for your library that you need to use. So to import data that is CSV format, you need to be able to use the package called readr. And then the function for importing the data is called read_CSV. And then inside here, you need to specify the path to where the data is. So in my case, the data that I'm having is in Excel format. Okay, so I'm assuming within your working directory, you have a data folder that contains a data set called marketing customer value analysis.xlx. So that is an Excel file. And to import an Excel file, there are two packages that people normally use. There are two packages. One is called OpenXLX. Another one is called readexl. So readexl is the most preferred one because it's much faster and can import data that is much bigger compared to OpenXLX. So since you have already loaded the package you're using, which is readexl, and I can be able to check search whether it's loaded by typing its name under the packages tab. So read Excel, as you can see, read Excel files. So to import the data, I have to give it a name. So I'm calling it bankdf, and then assign it to specify the function for importing the Excel file, and then the path to where the data is. So the good thing about using an R project is I don't have to specify the whole path. I just need to specify the subdirectory where the data is located. So if I run this, it should run without any problem. So once it successfully runs, I should be able to see the bankdf under the section data. So as you can see, I have my data that has 234 observations and 24 columns. So that's why we call it a two-dimensional object, because it has rows and columns. So the data that we are going to use today was collected from some marketing campaign by some insurance company. They're offering some, products to their customers. And then they were recording the response rate of the customers. So to subset data frames, there are two ways. You can either use a package or you can use base R. So I'm going to showcase the different ways in which we can do this. A package I'm going to use dplyr. So dplyr has a really nice verb or function called filter. It's used for subsetting. In subsetting rows, when subsetting columns, there are different verbs that you're going to use. So you're going to show all this. So the first thing I'll ask is, has everyone tried importing this data into Excel? Who is having an issue importing into R the data? Shalmet? Does everyone have the data within R? Okay, I think, okay. In the beginning, we had a session where you're creating a folder to store everything. I don't know, I hope everyone has a folder, and then they have a data folder. Sorry, open the wrong one. A data folder with data inside. Okay, so once you have a data folder with data inside, so let's go back to RStudio, and then click on File, and then New Project. File, New Project. But then I have to close mine first. So let's go to File, and then New Project. Sorry, File, New Project. And then you're going to have a dialog box asking you, how do you get the project? So select the second one, which is the second one. And then I'll specify where the folder is, your folder you're working with, where is it? So you just have to browse to where it is and then select. So in this case, maybe my folder is maybe generic, for instance. And then open. And then create project. So once you have a project, it's very easy to navigate the different folders within the project. So once you have the data inside, RStudio. You should be able to see it on this environment, the data pane. So you're good. Okay. So the first thing you need to try to see, like check the structure of your data. Like how many variables do I have? How many observations? What are the variable types in my data? So I'm going to use a function called glimpse. So glimpse is a function for viewing, checking the structure of your data. Like there are some people who use the str, like str, which is the structure, and then they specify the data set name. But then I love using glimpse because it looks unique. So as you can see on line 148, you can see like percentage greater than percentage. So this one is called a pipe operator. So a pipe operator, it allows you to structure a sequence of operations. So it basically takes whatever is on the left as an input to whatever is on the right. So when you look at this code, I could just have done this, like glimpse, then in brackets, I supply the dataset name. But then to make it look maybe fancier or easier, I can say bank, start with bank, which is my input, put the pipe operator, and then the function that I want to implement on bank. So if I run this, I shall be able to see the structure of my data set. So if you look at the output, you can see the number of observations, number of variables, and the variable names and the different types. So an example would be, there's a variable called customer, which is the customer ID, and the type is character, so it's a string variable. So another variable, like the customer lifetime value, is of type double. So this is numeric because they are numbers. So basically you can see character, double, or DTM. DTM is a data type, is a date. So if you look at the variables, there are some that have spaces, some do not have spaces. And the one without spaces, they have some kind of character here, is called a block quote. Because essentially, like your variable should not have spaces, but then R allows you to have spaces, but then if you want to reference them, R has to put block quotes at the beginning and at the end of the variable. So anyone with a question or stuck somewhere in this chunk? The string is a base R function. It works so well. But then the glimpse is from, I think, the tidy select package. So do you know how to install packages? Yes. So go to packages and install the package called Tibo. Then you should be able to work. So anyone with a question on this section, or they're having some problems, you can raise your hand and then we can have one of that helping you out. So the first thing we'll do is we want to subset columns. We want to select or drop specific columns from our data set. So how do we go about that? Selecting columns. So you guys, I hope you have the data inside RStudio so that we can be able to try out this. Okay. So deploy a package, it has a verb called select. Well, the good thing with most of the R functions, like they're kind of English words. So like you just can select means picking something. So in this case, we are going to use the select a function to select specific columns from our data set. So the first instance is, how do you select one column, for instance? So to select one column, you can either use base R, where you just use the $sign to extract a specific column from your data set. So in this case, I want to extract the location code column from the bank DF dataset. So how do I go about that? So I specify the dataset name, put the $sign, and then the name of the column. Well, the good thing with R is once you type the dataset name and then you put the $sign, it's going to automatically list all the variables, then you just pick the one you want. So as you can see, if I just specify the dataset name, then $sign, then it lists all the variables, and I can just pick the one I want. So in this case, I want the location code. I'm good. So another way is you can use the braces to extract different columns. So as you can see, so I specify the dataset name, then the brace, then I put a comma because I want to keep all the rows. So because the dataset has 2 dimensions, the rows and the columns. So the first one is normally the rows, then comma, then the columns. So keep all the rows, but then extract only the location column. So if I run this, the location code is going to be a dataset that contains just the location code only. So let me try running it, and then you can see the outputs. So the first extraction, the location code 1, is going to store my output as a vector. But then if I use the second code, is going to store my output as a data set. So you can see location code is a vector when I use the $sign, but then if I use the block brackets, then I'm going to have my output as a data set. I can also use indices to extract columns, but then I need to know what is the position of the variable I want to extract in the list of variable names. So in this case, location code is at position 11. So if I run this, it will give me the same output as it gave me before. So any questions on selecting a column using base R? Okay, seems you guys are okay, we can continue. So if I have to use dplyr to extract columns from my data set, I'll use the pipe operator, where if I specify the data set name, the pipe operator, then the function for extracting, and then I specify the name of the column I want to extract. So if I run this one, it's going to extract and save as a data set. So the location code 1 is going to be a data set. But then there's another nice function from within R dplyr called pull. So if I use pull to extract a column name, then the output is going to be a vector. So you can try running these 2 lines of code. As you can see, my variable names are too long. And then dplyr also allows you to supply the variable names as a character string. So you can still use the same code, but then I put them in quotes. So select and then pull. So any questions on the selecting one column? So the next section is, what if we want to select multiple columns, for instance? So the multiple columns is just the same code, but you just add the more columns. So in this case, when you're using base R, you cannot use the $sign when you're selecting 2 columns. It's only applicable when you're selecting 1 column. So if I have to select more than 1 column, then I need to use either the variable names themselves, or I use the indices. So an example would be, I want to create a dataset called output 1, but then it should only contain location code and total claim amount. Alternatively, I can use the indices, which are the positions of the location code column and the claim amount column. So if I run this through, I should get 2 data sets. out to 2 with two variables each. So if I expand this, I can see I have location code, and then I have total claim amount. So just remember, you can't use dollar signs for selecting multiple columns. It's only applicable for one column. And then if I have to use dplyr, then it's the same function, select, but then I have to specify the different columns using a comma. So my first one is location code, second is total claim amount. And I can also not use the pool, because previously we tried using the pool function to extract the location code, but then it does not allow you to specify multiple columns. So in this case, just use the select function and specify the variables, which can either just call them as the way they are from the data, or put them in quotes. Like, it doesn't have an issue with you putting them in quotes, as you can see in this second example. So another way could be, you can create a vector with the variable names separately, and then just call the select statement and pass the name of the vector as an object, as an argument to the select function. Then you should be able to create a data set called output2 with just the 2 columns that you have put in your vector. So you can try running this chunk and see if you get the output that you desire. If there's an error, you can let us know so that we can help you out. Okay, so any questions on selecting multiple columns? So maybe let me quickly go through the next section, then we can have a 10 minutes break, then we can come back for the next session. So another fancy way of selecting columns is using patterns. So I don't know how do I say it. So R has certain helper functions from the tidy select package. So the first one is like starts with. It's a function where you specify the prefix at the beginning of the variable name that you want to select. Another one is ends with, where you specify the suffix of the variable name. So if you have 2 variables that are ending with a specific character, you can always pass it to the ends with function, and then R will just select only those columns that are ending with, maybe if it's type or month. Another one is contains. So contains will just search for strings that contains a specific string that you have specified in the contain as an argument in the contain function. So another one is everything. So everything will just pick all the variables. So basically it's used when someone wants to order variables. So for instance, you might have an ID column that is appearing maybe somewhere in the middle or maybe at the end of the data set, but then you want to bring it at the beginning. So you can just say select the ID, then everything else. Another one is the last call. So the last call selects the last variable, but then you can specify a different offset. So the last call, it has an argument called offset. So by default, offset is 0. So that means it's going to pick the last column in your data set. But then if I want to pick the second last column, then I need to put offset of 1. If the third last column, offset of 2. So I have a few examples just to demonstrate the different functions. So an example would be, if I look at my variables, there are some variables that are beginning with the word month. So in this case, I want to get a new data set called stats, which is equals to bank, then select all the variables that starts with a word called month. And then the good thing with all these functions is that they ignore the guess of the, if I look at the documentation of the starts with, maybe it will give me here. So to search for any information about a function within R, just put either double or a single question mark, then the name of the function, you click enter, then it should be able to search for you within, I don't know, oh my, doesn't show it, or I can just type it directly. Okay, yes, so tidy select help us. So if I come here, there are some examples. And as you can see, by default, it ignores the case of the string you have supplied here. So I can put month, or I can put month in uppercase. So let's try to run this and then look at the output, like the columns it has picked. So I want all columns that start with the word month. So if I search for the start data set, I can see all the variables that I have, they begin with, there's monthly premium, month since last claim, month since policy inception. So they all begin with the word month. So another example would be the same, like I want those that end with the word type. So if I run this, then go look at my output, which is the end. So I can see like all these two columns, they end with the word type. So that's a very fancy way when you have variables. Because like mostly when you work with data from maybe a survey, for instance, like most of them normally name variables according to section. So maybe there's section A and then all the variables. So maybe you only need to work with the section A variables. So you can just put select where it starts with section A. That is going to give you all the variables from section A. So I have other examples for when to use since, because when to use the contains. So I want columns that contain the string since. So if I run this one and then come and look at the output, so you can see there's the word since in the middle of the variable names. And then last one is the last call. So I want the third last column. So I have to put an offset of 2. So if I look at my data set, the original one, the third last column is total claim amount. So if I run this, then I should have a data set that only contains total claim amount. So the last, if I open this one, it only has just in that one. So there are many other functions that you can available. You can read more about them, but these are the most common ones. So any questions on the helper functions? Okay, so let's discuss this last one, and then we can take a break. Sorry, I think I had to. So you can also select variables using logical expressions. So in this case, you're going to use the variable data types to subset them. So R gives you a number of functions to use. So there is like is numeric. You're going to select all the numeric columns. There is character, all the string columns. There is date. There is double. There are so many functions that you can use. So the only example I have here is for character. So I want to select all the character, all the columns of type character. So in this case, I will not use select. I'll use select underscore if. So so this data set should contain only character columns. So in this case, select if, then I specify is character. If I want to use is numeric, I can put is numeric or is date. It will only pick the variables that you have specified in the select if statement. So if you run this, my car data, they should only contain variables or contain strings only. Contain strings only. So deployer also has different other select variations. So apart from the usual select, there's select if, there is select at. There are so many. So depending on your use case. So you can try to use any that you want, depending on your use case. But I'm not going into details about the different variations. I've only talked about select if one. So in the next session, we are going to talk about subsetting rows. Like, why would you want to subset rows? Of course, you want to keep cases that you want to analyze. You want to keep rows that you want to work with. And there are different ways of subsetting rows. So I'll talk about each scenario one by one, and then any questions, just shoot them from me. So an example of like, you could be having a column with missing data. So you don't want to keep missing data because it's not helpful to you. You can keep them, you can drop them, or maybe you can think of doing it, maybe imputing them if you want to. But then if I want to subset rows and drop the missing ones, then I can just use some functions within R to do that. So deploy has another function called filter. Normally they are called verbs. I don't know why, but the filter verb is normally used to keep or drop specific rows in your data set. So the first scenario is, like, suppose you want to filter numeric columns. So for numeric columns, the most common operators are these ones, like greater or equal to, less or not equal to. For filtering, they are called relational operators. So I would like us to, if you look at the income column, the people who have like zero income, some are earning some money. So the goal of my filtering in this section is I want to drop those with zero income. So the first thing I'll do is, let's look at the income data set. Let's look at the minimum value, the maximum value, the mean, the median, just see its distribution. So the base R has a function called summary, where the argument is like a numeric column that you want to summarize. So for example, I want to summarize the income. And as you have talked in the previous section, if you want to subset a one column, you use a dollar sign. So if I run this, I should be able to get the output where I see the minimum is 0, then the maximum is around 100K. But then I don't want to analyze people who have no income. So how do I go about that? I use the filter function. So this is how it works. So just the same kind of select, the same structure. You have to specify the new data set name and then assign it to, now you have the bank data set, pipe operator, and then filter. How should I filter the data? Only pick where income is greater than 0. So if I run this, then my data set should not have people with 0 income. So to see whether the filter function has worked, I'll do another summary to check the output. So let's run this. So as you can see, I don't have any 0 income the way I had before. So now my minimum is around 10K. I still keep the maximum. Okay. So if I want to use base R, for instance, maybe I don't like deployer for some reason. Just the same function, but then I have to specify data set name, block brackets, and then where the bank, the income is greater than 0. So as you can see, this expression is coming before the comma. Before, when you are subsetting columns, because columns is the second, now we are typing the variable name here. So with this statement, I'm saying just check where the rows that have income more than 0, and then keep all the columns, comma, keep all the columns. So if I run this, I should get the same output. My minimum is 10K, maximum is still the same. So whichever one you fancy, you can go ahead and use it. So any questions on the filtering a numeric column? Are you getting some output or an error? If you have any error, just raise your hand and then Kigen or Shamit will help you out. So my assumption is you guys are okay. So I think we can continue the next one. So the second scenario is I want to filter rows that are within a specific range. So deploy has a function called between. So if I look at its documentation for between, so they ask, do values in a numeric vector fall within a specific range? So if you look at the structure of the function is, you supply the column that you want to filter, you define the lower bound, which is the left, then you define the upper bound, which is the right. So if you look at my function here, so I'm filtering, but then I want to filter people with income between 20K and 30K. So this is my lower bound, this is my upper bound. And then keep in mind that these ones are all included. So I'll have people with 20K, like it won't leave them out. So if I run this one, I should be able to summarize the data, the new data set. I should have incomes between 20K and 30. So any questions on the filter using the between function? So I can also use base R to do the same. So just the same structure of code. You specify the bank dataset name, block brackets, and then now supply this between function. But then I have to use a $ to extract the income. I don't know if you have noticed, but whenever we are using, if you want to apply a function to a specific column, you need to be able, if you're using base R, you need to use a $ every time. But then if I'm using dplyr, I don't have to. I just have to supply income. Because once I say, I specify like take the bank data set and then look for the income column and then subset. But then if I'm using base R, I have to make sure I use a $ every time. So that's why like someone will want to use dplyr because it's more cleaner, like no need of having to specify the $ every other time you're analyzing the data. So anyone with any questions on how to use the between function? So you can try it out and see if you get the outcome that's supposed to be. So another thing could be, I want to subset a column that is not numeric, but it's of string type, it's a character. So I'm going to use the vehicle class column to demonstrate how to filter string columns. So the first thing I want to do is, I want to extract the vehicle class column from bank dataset, and then I want to see the unique values. And base R gives you a fancy function called unique. So it just basically takes the whole column and then looks for the unique columns. So if I run this, I can see I have around six vehicle classes in my data set. So there are different ways of extracting character columns. So the first one is an exact match. So exact match means I have to specify the name the way it appears in the column. So for instance, I cannot have sports car with a small s, lowercase s. It's going to throw an error because it's going to search through the column, but it doesn't find sports car with lowercase. So in this case, just the same case, use the double equals, filter where the vehicle class is equals to sports car. So if I check whether this has worked, like I do a unique, so I check the vehicle class column from the new data set I've created. I only need to see sports car. I shouldn't see all the other ones. But then if there's an error, of course, I'll always give you an error if it's not matching. So another thing would be, I want to subset more than one vehicle class. Like I want a data set that contains maybe a sports car and a luxury car. Then I cannot use the equal sign to filter because it only requires you to supply one character. But what if I have more than one? So how do you go about that? So R provides you, I don't know how to call this, it's called the match operator. Percentage in. So it allows you to be able to subset when you have more than one object you want to subset. So an example would be, I want to keep all the rows where the vehicle class is either of class 2 door or class 4 door. So what do I do? How do I go about that? So I just use the same structure of the code, filter, then the vehicle class. Then I use this one instead of the double equals. Now I'm using this one, and then I wrap the two vehicle classes in a vector. So I have to put them together using this combine operator. If I don't put this, it's going to throw an error. So then it's going to search through the data and look for anywhere where we have these classes, and then it's going to give me the output. So let's see whether this one works out. So as you can see, we have 2-door and 4-door cars filtered out. So this is a very common way of subsetting, because most times you will want to like match more than one vehicle class or match more than one value. So suppose I want to eliminate the 2 car classes. Like, how do I go about it? So I need to use the exclamation mark before the variable name. So it's just the same code as before, but then add an exclamation mark before it. So this one should give me the vehicle classes except the 2. Except the 2. So I can see I only have SUV, luxury, sports, and luxury cars. So any questions on exclamation mark? It has to always come before the column that I'm subsetting with. Okay. Let me see how many more I have. Okay. So this is a little bit, well, complex, but not so complex. So you can also use pattern matching functions to subset your data. So there are 2 common functions that you can use. There is one called grepl from base R. There's another one called strdetect from the string R package. So let's look at the documentation of the structure of the grepl function. So you can always come under help to search for anything you want. So it's used for pattern matching. There are so many functions, by the way, that I use for pattern matching, but I'm going to use the grepl one. So for the grepl, you have to specify the pattern. Like, what should grepl look for? Should it look for an E, an F, or a specific character? And then X now is the column you're trying to search for. And then the other arguments, they have defaults. You don't have to worry about them. The only thing you need to worry about is the case. Because if I'm looking for rows that have maybe a character, maybe called car, for instance, but then the car in my data is uppercase, and then I supply a lowercase, then it's not going to give me the output unless I say ignore the case, ignore the guess of the variable. So the default is always false. So every time unless, make sure you put ignore case is equals to, ignore case is equals to false, will keep the case. But then if I say ignore is equals to true, then if I supply an uppercase, lowercase, whatever case, we're going to be able to match it. So I want us to try out an example on how you can use the grepl function to filter out rows. So if I look at the vehicle classes I have, there are classes that have the string do. So I want to only keep rows where the vehicle class contains the word do. Maybe I might want something different, like I want the one that have maybe the string SUV. I'll supply it as the pattern. So in my example that I have here, I only want to keep the ones that have do. As you can see, like the do in my data, the first letter is capital. But then I have supplied all of them lowercase. But then I have said ignore the case is equals to true. So it will still work. So filter, and then the function grepl. So search where in vehicle class where there is a word do, and then keep it. So if I run this one, my output should only contain the one that have do, do, do. So if I want to negate this, like I want to keep the ones that don't have the word do, I need to add an exclamation mark before the grepl. Like if it contains a do, skip it. Don't keep it. Keep the other ones. So if I run this, I should not get anything with a do inside. So the strdetect, you can also use it. But you have to install the string R package. So the string R package contains a lot of functions you can use to manage strings in your data. Like you can use to replace strings in your data, I don't know, match strings, search the location of specific strings in your string. But then we're only going to use the str detect, because let's look at the documentation of str detect. Oh, sorry, I need to have loaded the package first. I don't know if I have it. So load the package. Let me see if I can get it. Here, detect. So if I look at the structure, it's just the same. I have to supply, but now it's opposite, because for grepl, I have to begin with the pattern first. But then for string detect, I have to begin with the vehicle class and then the pattern. Then I'm good. But anyway, most time I like using the grepl function because I don't have to load so many packages into my workspace. Let me see. So what if I want to use more than one condition in my filtering statement? Like I want all the females who are more than 30 years old. How do I go about that in using the filter? So you only have to specify the filter statement, but then separate the two conditions using a comma. So I want to keep vehicles of type class where the owner of the vehicle has more than 2 policies. So I just say vehicle class is equal to sports car, comma, number of policies is greater than 2. So it's going to keep, this is an and expression. Vehicle class equals to this and policy more than 2. So if I run this one, I should be able to get, so if I do a unique on the new data set, I have sports car is equals to, the car is equal to sports car, but then the number of policies is more than 2. But then sometimes you might want to use an or statement, like just keep where they have more than 2 policies and the gender is female or gender is female. So in that case, I have to use this character here. I don't know. Yeah, I have an exercise. Oh, so. Okay, so I have to do an or. So let's try some exercise. Then when we come back, we can talk about the last section where you have to use other filter functions. Okay, so the exercise is, if you look at the data set, there's a column called response. So what I would like you to try out is select all the rows where the response is equals to yes.
You need to do it now.
Yeah. So if you have any errors or issues, you can always ask for help from Shamit, Keegan. They can help you out. So because of time, I would like us to go through the exercise together, and then we can wrap up. So the first question was, using the response column, select all rows where the response is equals to yes. And I think as Chris has explained, if you want to reduce the number of rows using a specific condition, you need to use the filter statement. But then if you want to select columns, use the select statement, select verb. So just to try out, the first thing I need to do is, I need to specify the name of my new object that is going to contain only those with the yes as a response. So I can give it any name. I can even call it yes, and then assign, specify the data set name, which is bank df, and then I need to specify the pipe, and then now the next step is specify the filter function. And then how do I want to filter? Pick the response column. Sorry. Response, it should need to be equal to yes. So the thing is, the fact that response is a character variable. If I want to filter it, I need to use quotes when I'm specifying the condition. So in this case, specify, yes. This is just it. So if I run this, I need to be able to get a column only containing yeses under. You can try, so if you click on a column, kind of a way of sorting it. So if I sort it, I can see I have everything is yes. And then, so the next one also is about filtering rows. So I want people who are employed. So that means the employment status is equals to employed, and their income is between 40 and 50K. So in this case, I'm using an AND statement. And you have talked about how to filter when you have multiple conditions. You specify the first condition first, and then comma, second condition. That means if you are using the AND. But if it's an OR, then you need to be able to specify the first condition, and then put the, I don't know, that's the name of the OR operator. I think it's like, where are you? This one. Operator, then the second condition. But in this case, the question is asking like AND, where you're employed and you're earning between this amount. So just the same case. Maybe I can call it DF, the new object, and then bank DF, then filter. So my first condition is employment status. Status is equals to employed. And make sure you type the same way. Don't put the first E as a small letter because it will not work. And then, and income is between 20K and 30K. You have already learned how to, if I want to filter values within a specific range, I can use the between function. I can spell the between, and then X is the variable. So the variable is income. And then what is the lower bound? My lower bound is 20,000. And then the upper one is 30,000. So this one should be able to give me the output that I desire. So if I have my, oh, wow, something is wrong. Oh, employed, oh, it shouldn't have, yes. So my DF, if I look under, I can just scroll through to check whether I have the output I need. What is the employment status variable? Oh, at the beginning, Is someone employed? There you go. If I try to sort it, I see everyone is employed. If I look at the income column, not sure where is it, I should have values between 20 and 30K. Okay, so the last question was asking, select all columns that start with an E. And I think we had already talked about the different select helpers we have. We have the ends with, starts with, contain, have the last call. But in this case, like select columns only that starts with an E. So in this case, because I'm selecting columns from a bigger data set, I need to use a select statement. So I can get a name for it just the same way, bank. Then I have my pipe. And then I do select. Then I say starts with, yes, I use a starts with. And then the player is going to suggest so many functions for you. And then the string E. So if I run this, so I have a data set called E somewhere. Sorry, it's called calls. Calls. So like all the columns I have should start with an E. So like I think from now you can see like where you are stuck and where you are stuck. So you have any questions there, maybe you can ask. Okay.
So I think we can clap for Fridah.